On slide 106, I will give you an LTA example with these kinds of error messages referring to non-identification. We start with a simple LTA example, and that's output 2, so it's a run without covariates. And we get two kinds of messages. First one has to do with loaded thresholds that approached extreme values and were fixed. These values imply probabilities of 0 and 1. In the model results section, we note this by having 0 standard errors and 999 in the z-score and p-value columns. We're going to take a look at details of how this happens. The second message has to do with multinomial loaded parameters, fixed again, to avoid singularity of the information matrix. So here we raise the possibility that the model is not identified, but it may be empty cells in the joint distribution, that is 0 probabilities, and we're saying that we fix these 3 parameters. We're going to take a look at the details of that. Both of these error messages are innocuous. That is, there is no problem with this model, but I'll show you how you understand that that is so. So on slide 107, we take a look at the first error message, the large thresholds and 0-1 probabilities. That has to do with the measurement model estimates. You know, we have these probabilities for the latent class indicator as a function of the latent class they're in. The low class, the medium class, and the high class. And we notice that several of these entries are at the edges of probabilities, zeros here and 1, probability 1 up here. That corresponds to the model results, the estimates shown on the right for classes 1, 2, and 3, that is columns 1, 2, and 3. Here it's shown for C1, but we know that they're the same for C2 and C3. And we see here that site and words in context have fixed values, large values, and 0 standard errors, and 999 for the z-score column. So that's a case then where 15, a threshold, is fixed at a very high value so that the probability is small to exceed it. The probability is 0 down here. We fix it because we know that we get a 0 also if we have fixed it at have the value 15, 16, 17, etc. Doesn't matter. So in that direction of that parameter value increasing, the log likelihood is flat. So we have a singularity problem here if we let it be free. So it's an example really of empirical non-identification, because we know that these thresholds are in principle identifiable with other data. But in this case, when they're used to represent these 0 probabilities, they need to be fixed. So it's an innocuous problem that has more to do with computations than important issues of the model. Now, what about this 0 here? Well, that corresponds to this value. There we didn't have to fix it as such a high value. So we get the standard error and a z-score here. That means that this 0 is slightly bigger than that 0. So it's like 0, 0, 0, 1 versus that being 0, 0, 0, 0, 0, 1 perhaps. But it's the same principle. We just don't have to fix it. For the last class then, we fix the first item to minus 15. That is, the threshold is very low and the probability is 1 to exceed it. So that corresponds to that 1. So once again, it's to avoid the flat likelihood in the direction of this getting smaller and smaller negative, or larger negative rather, going to the left, and we have a 0 second order derivative, and would get singularity if we don't exclude that parameter when we invert the information matrix. The second message had to do with transition probabilities, being 0 and 1. So here's what it said: one or more multinomial loaded parameters were fixed to avoid singularity of the information matrix. And we have these 3 parameters here that are fixed. So if we look at the transition tables, we have C1, C2, C2, C3, C3, C4 here. We note that we have zeros here in the bottom row, but we're saying C2 number 1, that's column 1, and C1 equals 2, that's this value. And the next one, C2 2 and C1 2, that's this value. So why are those fixed and not these? Well, that has an explanation too. If you remember the logit parameterization, in that parameterization you have the intercept parameters A here on the lowest row, and up here you have B slopes, A plus B, A plus B. So the way that hangs together is shown in this slide here. If you look at the model results, the A parameters here for C2 1 and C2 2, so that's A1 and A2 in that C1 C2 table, they're very large negative logit, not a threshold but a logit, means a very small probability, 0. Now that value is not problematic by itself. It doesn't trigger the condition number threshold saying it's singular, but when it combines with the C22 regressions on C1, you see that you have very high values here. So this is, for instance, C2 number 2 and C1 number 1. So C2 number 2, so minus 25.999 plus 26.619 is going to be slightly positive, and that then corresponds to these positive probabilities in the transition table. So it's not triggered by the error message, not triggered by the intercepts, but by the combination of intercepts and the slopes, because you can make this arbitrarily larger, minus 30, and just make that a little bit bigger, positive, and get the same probability. So you have that indeterminacy and therefore a singularity and need to fix something. And the reason Mplus fixes the intercepts is simply because, the slopes is simply because the slopes come last. If you look at Tech 1, the C2 parameters are numbered 18 and 19, whereas the C2 on C1 parameters are having a higher numbering, 25, 27. These are the B slopes. So the occurrence of the singularity doesn't happen until you get to the B parameters, and they just happen to come last. Now you note here also that the last parameter mentioned here is 35. So 35, and there were 35 parameters in the model. So Tech 1 lists as number of parameters, all parameters, even the fixed ones. And that's also listed in the model fit section. Nevertheless, those fixed parameters do not enter into the information matrix, and it's not part of what gets inverted. So once again, this is innocuous, and all you have to do is take a look at these zeros and ones, and there should be as many of those. I'm talking about these 2 zeros, never mind the last column that just had to add up to 1. And the third one is C4 on C3, so that's C4 2, second column on C3, so that's 0. That 0 and those 2 zeros correspond to those 3 messages there that are fixed. Okay, so that's innocuous. Let's go to another example. RI-LTA, output 9. So that's quite a complex model. It's a model with a covariate, and it's an interaction model. And that was a model that we said wasn't really needed. The main effect model was okay. So I didn't even bother to reorder the classes in the natural order that we like for interpretation. The log likelihood is the same whether you reorder or not. Here you have a warning that the sample covariance matrix of independent variables in class 4 is singular. So that's a new message. That's one message that we're going to talk about. And then you have a message about the standard errors of the model parameter estimates may not be trustworthy because of a non-positive definite first order derivative matrix. Condition number very low, certainly lower than -10. And it's a problem of C2, C1, so we know how to deal with that, how to look at that. Probabilities of 0 and 1. And then finally, one or more multinomial loaded parameters were fixed to avoid singularity of the information matrix. And here it's a number of parameters that were fixed, and we're going to take a look at that error message. Then we have on slide 112 taking a closer look at the warning the sample covariance matrix of the independent variables in class 4 is singular. So here we have the situation that if you have a class-specific regression, as we do in the interaction models, you have C2 on X has a specific slope for each C1 class. Those regression slopes are not identified when the class-specific variance of X is 0. You have to have a variation in the predictor. And the information about class-specific variance as a means for covariance is given in text 7. Now this class 4 is the first class where this problem occurs, and it refers to the fourth latent class pattern listed in text 7. So they're listed in the order 1, 1, 1, 1 for the 4 latent class variables, 1, 1, 1, 2, 1, 1, 1, 3, and then 1, 1, 2, 1, the fourth pattern. And then you get sample statistics weighted by estimated class probabilities for pattern 1, 1, 2, 1. And you see that the mean and variance is 0, which means that here there's nobody with poverty equals 1. They're all poverty equals 0 people, so no variation. And that class pattern is, it's not reordered, so I don't know what the interpretation is, but 28% are in that class, but none with poverty equals 1, apparently. So you have to fix that parameter, and that's again an innocuous fix. It just means that we can't estimate that parameter. So that's what we're referring to here. The fixed parameters refer to C on poverty here, whereas the first bullet here and the last 3 have to do with C on C. But it's C on poverty that triggers the message that we talked about. So C on C, you know what to do, what to look for there. But here we have C on poverty. And you see these fixed values in the model results section. And the technical 15 section, final class counts and proportions for the latent classes based on the estimated model, tells you those frequencies. And you see then, well, let me show you in output 9 what you see. So output 9, let's take a look at the model results first. And we have to scroll down to the class-specific regression. So in latent class C11, latent class C12 and 3, we have C2 on poverty, and C21 on poverty, and C22 on poverty. And you see these fixed values, 999, large negative values. So those are slopes that can't be estimated and should not be really interpreted. And we have some more here as well. And as we go down, there are probably further ones here also. It's just that we don't have enough people in the cells, as we will see in a second. So if you then scroll down to Tech 15 and final class counts and proportions for the latent classes based on the estimated model, you see then the latent class patterns C1, C2, C3, C4, and the various combinations here. And you see that many of the combinations have zero frequencies, zero probabilities. So that then makes you suspect that, yes, we have zero people, and or at least too few people to have variation in the poverty covariate. What you might want to do, if you really distrust that this is so, you could create the bivariate tables for C1 and C2 and look at that 2 by 2 table and see how many people are in it, and see if every cell has a variation in the poverty covariate or not. So that's a little deeper look into the error messages. Hope it was helpful.